Okay, so 8.2, we are simplifying logarithmic expressions. So, same concept here, right? What we need to understand is how to go both ways, how we can change them from log to exponent and how we can go backwards from exponent to log as well. Okay, so these first couple examples should be pretty easy because we remember how to change these, right? So we have base, what is my base going to be?
5.
5 to which power?
Half.
1/2 equals root 5. Okay, example 2, what's that going to be? Perfect, 3 to the negative 2 equals 1/9. Okay, so it's just sometimes hard going backwards, so now we want to change these to log equations.
32 to the 5th.
So we're going to go
32 equals 5.
good. Log base 2, and your base is always, a little bit smaller, and then it is of 32 equals 5. And I always kind of like double check myself by going, oh yeah, it'd be 2 to the 5th equals 32. I'll kind of say it back to make sure I did it right. Okay, example 4.
Oh wait, for this one, since it's a base 10, do you have to write the base?
Very good. Okay, so Sarah asked, since it's base 10, do I have to write the 10? What do you guys think?
No.
No. If you want to write it, can you? Yeah, it's totally up to you. So let's just do it that way. So it's going to be log of what? Log base 10 of, what's my number going to be next to that?
0.001.
Good. Equals
49.
negative 3.
Is that going to have to
Okay, number 5. What's it going to be?
Log 7.
Log base 7,
49.
49 equals
2.
2. Perfect. Okay, so do we kind of feel comfortable with this stuff here? Yeah? All right. So this next part, I kind of wrote out some steps for you. The first thing I would normally do is just set this problem equal to x. And then you're going to change the equation to exponential form. So how would I change this? Okay, does this look similar to 8a now? Yeah? Okay, so what would I do to end up finishing to solve this? I would change 49 to have base 7, right?
Yeah.
And that would be 7 to what power? 7 to the second. Okay, once...
Then you cross them out.
Right, then you can drop your bases. And my answer is
X equals 2.
x equals 2.
You look like we're checking. I want to make sure she was okay.
All right, example 2. So the first thing I would suggest doing is just put equals x. Then we're going to change this to exponential form. How do I change this to exponential form?
Like now, last problem.
Good. 3 to the x equals 1 over 27.
Wait, I have a question.
Ask me.
Is this how you get a negative on your exponent because the bottom is
So 27 is what?
3 to
3
the
to the
3rd?
3.
Very good. 3 to the third is correct.
Hey, I did that.
Oops, why did I write a 2? Not sure. Okay, 3 to the third. Now, how do I make it so that I bring it up and the bases are at the same spot?
Negative 3.
Good. So I have 3 to the x equals 3 to the negative third because I want to take this and bring it up. Just like when we bring them down to get negatives, I can bring them up and give it a negative. And then we drop our bases, and my answer is x equals negative 3. Do you think you guys could try 4 on your own? Or 3 on your own?
No.
No? You don't want to? Okay.
I don't know how to do that root thing.
Okay, so what's the first thing I'm going to do?
16 equal to x.
Very good. Equal it to x. Then we're going to write it as
4x.
Equals 16.
equals 16 root 4. Okay.
Oh, you do it by 2. can't you?
Maybe, okay, I showed you guys 2 different ways. Do you want me to show you with getting rid of the square root or show you a different way?
The easiest way. The easiest way.
No, you could. Can you like?
Well, because what happens is 16 is 4 to the second power, right?
Yeah.
4 is 4, like the square root of 4 is 4 to the what? And then all you do is add those exponents. So what's
4
2
and
plus a
1/2?
half?
2 and 1/2.
2 and 1/2. So this is really 4 to the x equals 4 to the 2 and a half.
Oh my gosh, it is so
Alright,
easy.
yeah, that's too hard. Is there another way?
Wait, is the square root always going to be a 1/2?
Unless this was a cube, and then it'd be 1/3.
Alright, wait, that's easy.
Okay.
Wait, so it's 4?
This 4 has an exponent of 1, and the root, if it doesn't tell you, is a 2. Your exponent always goes on top, and then the root goes on the bottom.
That makes it easier, guys.
So-
I think I got it.
I don't know which way is better.
I like it the other way. It's a little better.
The other way is you could get rid of the square roots.
No.
No.
But you just
I'm
square
not-
it, then you
I'm
can
not
put
doing
everything.
it.
Yeah, that's too complicated.
It's actually more work, probably. I think I agree. Okay, number 4, we're going to put equals x. How will I rewrite that?
By using 2x to the cube root of
Yes, good job. Okay, so 2 to the x power equals the cubed root of 1/4.
Now you can get rid of that by doing.
Okay, we don't want the fraction, right? So I'm going to change 4 because I'm going to want 4 to be base 2, right? So 4 is actually 2 to the second power. Okay, so I'm going to now rewrite this. I still have 2 to the x equals. I'm going to keep the cubed root, but if I were to take this and move it up, it's going to end up being 2 to the what? -2. And then now you're going to change this to a fraction just like we had with 4, the square root of 4. How are you going to change this one? Exactly. So you have 2 to the x equals 2 to the -2/3. Because -2 is my exponent, and so that goes on top, and the 3 is my root, which goes on the bottom. Which means that my answer is what?
-2/3.
Exactly. Do I need to kind of walk through that one more time?
You're just taking the cube and the exponent.
So one more time. 1/4. 4 is really 2 to the second power. I do not want that as a fraction, so if I bring it up, it's going to end up being 2 to the -2 power. Okay? McKenna, you still have like another, you still have more time.
Oh no, I know. I was gonna.
Okay, so then once we have it like this, we want to get rid of the root, and so it changes to -2 goes to the top, and then your root goes on the bottom. Your power exponent is the top number, your root is your bottom number of the fraction, and then you can drop your bases.
What did I tell you? I was pretty weak.
Okay, number 5. We're going to put equals x,
This one's tricky.
okay? And then what will I do?
So it's
1/2
Good, 1/2 to the,
x equals 16.
what base do you think we're going to want for this?
2.
2. So this one is going to change because it's very good. It's going to be 2 to the -1, and since there's already an x there, Clayton and Yelzar, we're just going to put an x next to it, right? Because -1 times x would be -1x. 16 is going to change to what? 2 to what power?
4.
Good. Okay, so now our bases are the same. We drop our bases. We have -1x equals 4, and what will I still need to do?
Divided by -1.
Very good. We divide by -1 to both sides. And we get x equals -4. Okay, do we feel okay with this?
Yes, ma'am.
All right. We already briefly talked about this, but again, if there's no base stated, then the base is 10. This is called a common logarithm. Okay, so on example 1, if we are changing this to be,
Do we set it equal to x?
still you can set it equal to x.
So 10x equals
Very good. So remember that this is base 10. So that'll be 10 to the x equals 1,000. 1,000 is 10 to what power?
10 to the x.
10 to the x equals 10 to the third, which means that x equals 3.
I got distracted.
All right. Again, example 2, we put equals x.
Then it'll be 10.
10 to the x equals 0.001. We want to change that to be base 10. This is really a fraction. This, if you were to write it not as a decimal, it'd be 1 over 1,000. If you want to think about it that way, 10 to the x equals 1 over 1,000. We know that 1,000 is actually... And do you know how I know this is 1 over 1,000? I didn't think... I probably need to talk about this.
Because the first one is tens, the second decimal place is hundreds, and the third.
Very good. It goes tenths, hundredths, thousandths. So anytime you want to change a decimal to a fraction, you take whatever number is here, which happens to just be 1, and you put it over whatever place it's at. So this went out to the thousandths place. So this is 1 over 1,000. Okay? And then we know that 1,000 is actually 10 to the third. When we bring that up, it becomes -3. So 10 to the x equals 10 to the -3, which means that x equals -3.
This is like a mix from last.
Yep, they go together. That's why we have an 8A and an 8B. Okay, example 3. Did you guys do that one on your own?
No, ma'am.
Okay, try it real quick.
10 to the second.
You can show me on your fingers what answer it is. Clayton, Yelzar, which answers did you guys get? Good.
Wait, did I get it right?
Nope, you're not paying any attention.
Am I getting it right?
Nope. Yes. Yes.
Oh.
Was that a negative in front?
Yeah.
Nope.
Oh.
Yes. Yes. There you go.
You just canceled.
Okay, so this is base 10, right? We put equals x, so we have 10 to the x equals 10 to the second power. There's no more work to do. We just drop the bases and x equals 2.
Oh, I did number 4.
Oh, then you got it right too. Okay, so again on number 4, we put equals x. This would be 10 to the x power equals 1 over 100. We know that 100 is actually what?
10 squared.
10 squared. So when I bring that up, it's going to be 10 to the
-2.
-2. We drop our bases and
I'll
X.
do the next one.
oops, x equals -2. You're close. Okay, example 5. What will I do first?
You need to do equal to x.
Okay, and then what?
10.
10 to the
X.
equals the square root of 10. We need to change that to be an exponent.
Wouldn't it be 10 1/2?
Uh-huh. So 10 to the x equals 10 to the 1/2, which means x equals 1/2. Okay, any questions?
No, ma'am.